So, what's really important then to remember is after you kind of get the whole big picture conceptually of what's going on in meta-analysis is we need to have some kind of fundamental result to look at. This is still a statistic, so it's still a quantitative method. So, what happens is we're going to need to provide the reader with a composite index of studies on our particular research question or topic. And that composite index is typically referred to as an effect size. It is an index of the impact of the IV on the DV. And if you've noticed throughout SPSS, as we've been working throughout the semester, I've allowed or encouraged you guys to click the little box in SPSS that is effect size. And almost all, I think everything we've done so far, maybe not t-test, I have to go back and check, has allowed you to actually click effect size on there and get something like a partial eta squared, which is one measure of effect size, which will tell you how much of an impact, what is the degree or the amount of impact that the IV has on the DV. So in meta-analysis, an effect size is computed in such a way as to account for procedural differences in past studies. So effect size in a true meta-analysis will do that. Now what I just explained is the effect size of one particular study, right? So if you're looking at the effect size of just one study, sorry, the camera is backwards from where I'm looking, then you are looking at just the effect size of that one study. And you can get an effect size from one study, but in a meta-analysis what we're looking at is the effect size of a lot of studies. So what's happening here is we are taking into account procedural differences, the number of participants, the type of participants, research settings, whether it's laboratory or field or somewhere in between, some combo, all kinds of other research characteristics. Is it the creator of the theory that's doing the research, or is it somebody else? There's tons of different things that people will take into account.